Hello to everyone. Today we start doing our next laboratory work, and by doing this laboratory work, you will be able to know how to create multiple regression model and in what way we can investigate its adequacy. But before we start talking about the theoretical information how to create multiple regression model, I want to emphasize that when we talk about multiple regression model, it means that we include into our model more than one independent variables. We denote all these independent variables like x's, symbol x's. So we have more than one independent variables. And before we start create the regression model, we should understand if between these independent variables present some linear relationship, because if this relationship will present, we call the situation like presenting multicollinearity, and it means that we need to do some steps to probably reduce the negative consequences of multicollinearity before we start create regression model, multiple regression model. So first of all, I want to remind you that when we talk about the multicollinearity, we talk exactly about perfect or exact linear relationship among some or all our independent variables. So we talk only about perfect or exact. And in this case, it will be a really very big problem if we do not extract the most collinearity independent variable, because in this way we will not be able to understand how our y will react on changing in some very correlated with other independent variables x's. So again, when we talk about the effects or consequences of multicollinearity, you should again probably remind from our lecture that depending on your goals, multicollinearity isn't always a problem. But for example, in the situation when you want to probably change your data set, and for example, if you want to include one more independent variable, it can cause such problem like you will have different values of your regression coefficients, and that's why it make impossible to or less possible to use or to disseminate your regression model to full population. So in this way, when we have big multicollinearity, it means that our regression model become more sensitive to changes in your data set. And of course, it will cause some differences in your predictions, in your forecasting. And that's why first step that you need to do, it is to detect if we have multicollinearity, and then do something that can reduce the negative influence of multicollinearity on your regression model. And then when you will doing this step, you can go to the next step and create your regression model. So That's why if we take a look at the guidelines according to doing this laboratory work, you can see that what kind of methods we will use to detect multicollinearity. It is the FARRAR-GLAUBAR method, probably the most popular method that we use in the econometric analysis. And now we need to talk about the algorithms. So first step, according to application this method, is to build metrics of correlation coefficients. So we need to build our correlation matrix. And you can see that each element of this matrix correspond with coefficient of correlation between the pair of our independent variables. So you should again remember that when we talk in regression, multiple regression analysis, if we talk about correlation matrix, it means that we talk about matrix elements of which correspond with correlation coefficients that reflect relationship between the pair of independent variables, only between independent variables, not between y and sum of x, but between different kind of our independent variables. So it is our a matrix of R, or it is matrix correlation matrix. So then we need to find the inversed matrix to matrix R, and we use another symbol to make the differences between two matrix, and we use for inversed matrix of R symbol Z. It will be our matrix Z, and you should remember that Z is our inversed matrix of correlation matrix R, and then it helps us to find the first are indicators that can detect if the general multicollinearity present in the range of all our independent variables. It is chi squared. So why we talk about general multicollinearity? Because when we use this kind of indicator, we can find the answer if in our full range of independent variables present multicollinearity, but we don't know between what kind of independent variables. Just find the answer if general multicollinearity present in our full range of independent variables or not. So we should estimate chi squared, this criterion. And for this reason, you can see that we need to use these formulas, and we also it will be also necessary to find a natural logarithm of determinant of our correlation matrix R. So how to do it into Excel, I will explain later. And now when we find this estimated value, we need to compare this value with table value, and if our estimated value is bigger or equal to table value of chi squared, it means that with some level of probability we can assume that there is multicollinearity between the factors. So we have general multicollinearity. And then we need to determine the question of which factors there is multicollinearity, and for this reason we need to find the next are statistical indicators F statistic, F criterion, and you can see that for this reason we will use these formulas, and you can see that we need to identify such many these criterions that correspond with number of our independent variables. It means that, for example, if we have two independent variables, we need to use to estimate f1, f2. If we will have three variables, it means that we need to find f1, f2, f3. And the most important thing that we need to use into this formula, it is getting information from our matrix Z. So from elements of our matrix Z that is inversed to our matrix R. And also I want to say that when we will build inversed matrix, I not only show you how to do it with function in Excel, but also how to do it in mathematically right way. And it will be probably a very long procedure, but I think that in this way you can remind a lot of information from your mathematical discipline. So then when we estimated this criteria, we need to compare each of your values with, again, table value of this criterion. And if your estimated value is bigger than your table value, it means that your independent variable, first, second, or for example, third, is multicollinear with others, and we are not sure with what kind of other independent variables this variable is connected. And to find the answer on this question, we need to do the last our third step into FARRAR-GLAUBAR algorithms. It is to find t-statistics. And to find t-statistic, we need to use the partial correlation coefficients. We were talking about these coefficients on our lecture. And when we detect multicollinearity, it is one of the necessary indicators that we need to calculate if we want to find the answer between what pair of independent variable we have strong linear relationship. So according to these formulas, we can define our partial correlation coefficients. You can see that for this reason we again need to use our matrix Z, our inverted matrix, to correlation matrix. And then it will give us necessary information that we put into next our formulas that help us to estimate our t-statistic according to each pair of our independent variables. And just using these formulas, you again should to compare your t estimated with t-table. And if your estimated value of t will be more than t-table, it means that with some level of probability or with variability of p, we can assume that between the factors of xi and xj, so between some exact pair of independent variables, present multicollinearity. And then you probably remember that when we have multicollinearity into our range of independent variables, we need to do something. So one of the simplest solutions for avoiding multicollinearity is just dropping one of the collinear variables. But you should remember that dropping a variable from the model, we may be committing a specification bias or specification error. So before this, to avoid these negative consequences, sometimes we can use other solutions. For example, in your laboratory work, we will use to eliminate multicollinearity some replacement of factors. And if this solution will help us in this way, we will include this relationship into our multiple regression model. But if not, we will doing dropping one factor from our next multiple regression model, and then after doing all this necessary steps, we will be able to create our multiple regression model in according to this kind of view, where we have our actual value of y, we have our again PRF of CRF function that represent our predicted or estimated variable of y, and of course we include our unobserved factors u into our regression model, and then by using methods of OLS, by minimizing the disturbances or minimizing the differences between our actual and estimated value of y, we can find our unknown parameters. In according to matrix approach, computation approach, we can use the same formulas like we used when we create our simple regression model. So it is the same, but the difference will be into our matrix of x's, because it will depend on the number of our independent variables which we must include into this matrix. And then of course we should find our regression coefficients. Then we need to investigate the adequacy, the reliability of our created multiple regression model, and for this reason into this laboratory work you will use the Fisher's criterion by using these formulas, and then you also should use the coefficient of determination. Then you make some conclusions, and then you should to find a predicted value of y and confidence interval by using this kind of formulas. And also, like we do it into previous laboratory work, we also should to define coefficient of elasticity. So it is the most necessary information that we need to describe before start doing this laboratory work. And we have our data set, our statistical data, and you can see that into this laboratory work we will have deal with three kinds of independent variable axes. It is our marketing costs, investment in production, and total costs, x1, x2, and x3, and how will income of the enterprise will react on each of these indicators. So our y, it is our dependent variable, is income of the enterprises, and we have again 15 observations and 16 observation. It is predicted value of our each independent variables. So we have 8 task that we need to do into our laboratory work, and we will able now to go to our Excel file and start doing first calculations. So now we open our Excel template file, and what we need to do, we need to copy our statistical data from Word file to Excel file, and we need to generate this Excel table where we have 15 observations according to Y, X1, X2, and X3. I will make all my calculation based on variant number 1, and I also fill the color, yellow color, all the cells where you need to change your numbers according to your individual number into your list group. So we have our first task, and this first task we can read into this place. We need to define a correlation matrix. So for this reason, we need to remind again the view of this matrix, and also we have the place into Excel where we will put the necessary information about the correlation between the pair of independent variables. So first moment that you should remind that all elements, diagonal elements of our matrix must be equal 1. Why? Because we talk about correlation between two the same variables, between x1, x1, x2, x2, xm, xm. So mathematically it will be equal 1 because the same variable is connected with oven values. So it is all diagonal elements must be equal 1. It is first moment. Second moment, this matrix is symmetrical matrix. It means that when we talk about correlation analysis, we talk about correlation coefficient, and this is a measure of relationship between two independent variables, x, 1, xi, and xj. And it doesn't matter for us if x2 relate to x1 or x1 is related to x2. It is the same. That's why it is symmetrical. It means that it is enough to define the three most important coefficient of correlation to fill all our metrics. And why I was talking about three kind of these coefficients, because our matrix R in this laboratory work has size 3 by 3. Why? Because we have three R independent variables. And we can talk about three kind of pairs between our independent variables. So we can talk about a relationship between x1, x2, x1, x3, and of course x2, x3. So it will be enough to define three correlation coefficients that describe the connection between the three pair of independent variables. And if we will calculate this correlation coefficients, it will be enough to fill all our matrix R. And the last moment that I just want to remind that when we talk about correlation coefficients, we talk about the indicator that is measure of linear type of connection. So we measure the linear connection between our independent variables. So how to define the first, for example, correlation coefficient. It's very simply because we can remind again our basic formulas of correlation coefficient that you used in the previous laboratory work, where you define the connection linear, the connection between x and y. And into this laboratory work, we just instead of, for example, xi, we need to use, for example, x1. So the first parenthesis, it will be difference between x1 and mean value of x1. And instead of y, we need to use x2, the second variable, x2. So we can use, for example, based on this formula, this connection between our two pair of variables. In this formula, it is between x1 and x2, but we, for example, instead of x2, we can use x3, and that's why in this case we will find correlation coefficient between x1 and x3, and then also we can use x2, x3, also put necessary a variable into this formula. In this way, find our necessary values. So let's start to do it and applying this formula. So you can see that first of all we need to find our parentheses that reflect the differences between some independent variable and its mean value. So for this reason, first of all, we need to define this mean value, and for this reason we need to use function average or средняя, and we use for this reason this kind of our first column, and then we just stretch this line and you can see that everything is correct. Good, we find it, and now we can define the first differences between each x1 and its mean value. And to simplify our calculation, we just fix it, our mean value, and stretch down. And then we can find that our sum of these differences is equal 0. It means that we talk about normal distribution of our range of x1, and it make us able to use OLS method. Then we need to do the same thing with x2, also fixed mean value of x2, and then mean value of x3, and then you can see that everything is good. Next, we need to multiply, to find multiplication between two kind of parentheses. So when we talk about x1, x2, it means that we need to use in numerator the parentheses, two parentheses between differences x1 around mean value of x1 and x2 around mean value of x2. So if we will change our correlation coefficients, for example, x1, x3, it means that we need to change x2, and instead of x2, I use x3, etc. So we need to define all this numerator components to define the numerator. So in this way, multiply by x2, x1 by x3, and x2 by x3 again. Then we need to just again stretch down. And in this line, you can see that I find the sum of all our values in the related columns. And next, in the denominator, we can see that we need to put into the square all our differences. and we should do it types by itself. And now we check, is this right formulas? Yes, it is the right formulas. Now we just can stretch down and find the sum of all these three components. Now, by using, for example, first formulas, we can put necessary information into numerator. So we need to find sum of multiplication of two differences, x1, x2. Where it is these are values, we should what to do? Divide by square root or korень in Russian, korень. Of two numbers. What? Sum of difference x1, x mean value x1, it is this kind of value, and multiply by x2. That's all. Good. Next, instead of x2, we use x3. So in numerator, we need to use x1, x3, x1, x3. It is this column, and divide by again korень or square root of what? x1 multiplied by x3. And the last one, it is between x2, x3, sum of multiplication, divide by, again, korень of multiplication, x1, x2, x2, multiply x3. Good. Yes. So you can see that we have necessary our pair between our independent variables, and we can use this information and put this information into necessary R place into matrix R. So you can see that x1, x2 will be, we put this value into this cell, x1, x3 into this cell, and x2, 3 into this cell. Good. Now we have all necessary element, and just use the symmetrical feature of this matrix, we can fill all the gaps. So x21 is the same x12, x31 it is the same 1, 3, and x32 it is the same 2, 3. Good. So it is the first method how we can define our correlation matrix. And the second method, it is more convenient and more simplest way, it is by using function correl. So we need to use correl, this function, to describe connection between x1, x2. That's why first massive, it is our x1, we put semicolon and then put x2. Next, it is again correl, but between x1, first massive, and put semicolon and put x3, massive of x3. And the last one, it is again correl, x2, x3. You can see that everything is correct, that we calculated in handle way, is related to what we found by using function in Excel. And now we again remember that all diagonal elements is equal 1, and we can put necessary information into necessary cells, and then we can use for further our tasks. Good. So let's take a look at the correlation coefficients. You can see that it is necessary to use some extra steps to define or to find the answer on the question if we have multicollinearity into our range of all independent variables. Why? Because you can see that between x1 and x3 exists very strong linear connection, very strong. And that's why it lead us to use extra one method, how to define and probably to prove that multicollinearity exists into our range of independent variables. And that's why we go to our next step according to using our FARRAR-GLAUBAR algorithms. And the first of all, what we need to do if we want to apply this algorithm, it is to find chi-squared criteria and F and T statistics. So three kind of statistical indicator. So if we recall the formulas, how we can define the estimated value of chi-squared criteria that can help us understand or evaluate the presence of general multicollinearity in our massive of data set. You can see that we need to find the determinant of our matrix R. So to find the determinant of matrix R, I want to change my presentation and just recall some mathematical rules and mathematical knowledge about this kind of question. So what is determinant of matrix? You can see that it is a special number that can be calculated from a square matrix. In this example, you can see that we have 2 by 2 size matrix 2 by 2, but we need to define matrix with size 3 by 3. That's why we go to another example, 3 by 3 matrix. And in English books, you can find a little bit different way probably than we usually use to define determinant. And you can see this kind of explanation how to do it, how to find determinant for the matrix of 3 by 3. And for this reason, you also can apply this example. But probably the most usual for us is the rule of triangle, if you remember. And according to this rule, you can see the example how to define the determinant for a matrix 3 by 3. So let's describe this example. So first of all, what we need to do, I just probably to your more convenience, I will draw the line and this triangle, and then I will delete this, because when we talk about this approach, we need to, we can divide on two parts all our calculations. It is triangles and diagonal with pluses by sum up, and then we need to subtract again the sum of other diagonal and opposite diagonal and opposite triangle. So we start doing from this first diagonal, so we need to multiply 3 elements. Then according to this we need to what to do? -2 multiplied by 1. So we start from here and we draw our first triangle, and he ended into this place. And then last our triangle that we need to sum up, it is 2 by 2. 2 by 2 for -3 and for 2. Good. So all these 3 components we need to sum up. And now I delete all of this, and now another probably green. I will mark opposite component that we should to extract. So you can see this big parentheses, and we need to extract from the first our 3 components, we need to extract next 3 components, the sum up of these 3 components. So what is this 3 components? It is first, it is line, the opposite diagonal line, it is first. Then be careful, -2 by 2 by 5, -2 by 2 by 5. And we end into this place, and then we take 1, then -1, -3, and 1. So in this way we will able to find our matrix. So now we will try to apply all of this to find the same indicator into our Excel file. So we change demonstration. So what we need to do? Again, 1 multiplied by 1, then plus this, multiply on this, multiply on this, and plus this, multiply on this, and multiply on this. Yes. Then minus opposite side, opposite diagonal, this, this, plus, then start from this, plus, and this. Now we need to check, is this correct calculations? We can use Excel function mopred, in English it will be mdeterm, and now mopred, and we need to select our all metrics and put OK. So you can see that everything is correct. So it's very good. It helped us to find his squared criterion into this place by using these formulas. So what we need to do, it is minus, then open parentheses, and it will be equal our 15 will be equal 15. Good. Then -1, -2 multiplied by probably we also open parentheses, -2 multiplied by m it is number of independent variables equal 3, x1, x2, x3 plus 5 divide by 6. Then we need to multiply it by ln, natural logarithm. For this reason, we use ln, function ln, from the number of our determinant, and then we enter. Good. So we find that our squared criterion is equal 54.82. And now what we need to do, we need to compare this value estimated with what? With table value. How we can find table value? Again, by using statistical tables, but in Excel we have some function he2ober, he 1 minute, he2ober, this English version of this function chinv, and then what we need to do, put level of probability, it will be 0.05, then put semicolon, and degrees of freedom. For degrees of freedom, I want to demonstrate our guidelines, because in guidelines you can find these degrees of freedom. This what is our degrees of freedom: 1 by divided by 2 multiplied by m, and multiplied by m minus 1. So m it is equal 3, and 3 minus 1 it will be 2, 2 divided by 2 it will be 1, and 1 by 3 it will be 3. So it will be equal 3. We put 3 like degrees of freedom and enter. So what we have, again, we go to our guidelines, and you can see that if our estimated value is bigger or equal to table, so our 54 is bigger than 7, means that there is multicollinearity between factors. It means that we have general multicollinearity in the range of our independent variables. So next, what we need to do next? We need to go to T and F statistics. So first of all, we need to find F-criterion. F-criterion, we need to use these formulas. And you can see that we need to know the elements, the right elements of our matrix Z. What is our matrix Z? It is inverted matrix of our correlation matrix. And today we will use two approaches. First approaches again will be based on your knowledge of mathematics, how to create inverted matrix. This reason we open the necessary mathematical information how to inverse a matrix, and you can see the steps, necessary steps that we need to do. It is calculate the matrix of minors, then cofactors, and aggregate matrix, and then we need to divide by 1, divide by the determinant, each kind of elements of aggregate matrix. So I recommend you to read carefully this information by yourself when you will doing your calculations in your Excel file. But now I want to open the Ukrainian version, how to do it, because it will be more convenient for you, I think. So now I want to underline that we need to, if we want to inverse the matrix in Handel way, yes, we need to know such important information. First of all, we need to define determinant, and we have it. And also we need to find all elements of educate matrix. Educate matrix, it means that we talk about this kind of matrix, and it corresponds with the minors. And for this reason, I want that you read the scheme about the signs of our minors, and then we will use this information to define each element of our educate matrix. Need to find 9 elements of educate matrix. So for example, to define first element, it needs to write -1 into the square into degree that is equal the indexes of this first element. For example, 1 plus 1, if we want to define educate for element 1, 2, it will be in the degree of 1 plus 2. So it is related to the right sign of each of our educate elements. -1 in degree of 3, 1 plus 2 is 3, and we need to subtract first row and second column. And then we need to find the determinant of the rest matrix 2 by 5 minus multiplication of -1 by 4. It will equal -14. So go to our Excel file and illustrate this principle to our data set. So first element of our educate matrix will be equal what? It will be -1, and we put into parentheses -1 because we want to show the right sign. That's why we need to put in take degree, and degree it will be 1 plus 1 because it is first element with indexes 1 plus 1, yes, plus 1, and then multiply on what? You can see that we need to subtract first column and first row. So what we need to do? We need to multiply 1 by 1, 1 multiply by 1, and subtract for this element, multiply for this element. Good. Next, it is element 1, 2. So that's why it is again -1 in degree of 1 plus 2. That's why it will be minus negative, yes, sign. And then we need to multiply by what? We need to subtract first row and second column. So we need to multiply this by this and subtract this by this. Next, again, we need to write parentheses -1 degree 1 plus 3. It means that we need to subtract first row and third column. So we need to multiply this element by this element and minus this element by this element. What next? Go next. Again, we open parentheses -1 degree 2 by plus 1 and multiply by what? We need to subtract the second row and first column. So be careful. It means this, multiply for this element and minus this element on this element. Next, again, 2 by 2. And be careful. What does it mean? 2 row, 2 column. This multiply by this and subtract this, multiply by this. Good. Next. Next is again 2 by 3 multiply by what? We need to subtract the second row and third column. The second row and third column means this multiply by this minus this multiply by this. Good. And the last our row, again open parentheses, degree, 3 by 1 and multiply by what? We need to subtract first column and third row. So it means that we need to multiply this element by this and subtract this by this. Three row and second, 3 row, the third row and second column. This multiply by this minus this multiply by this. No? Something wrong. And instead of multiply, I put parentheses. And the last one, 3 by 3. It is the most complicated part of this laboratory work. So subtract third row and third column, and we need to multiply 1 by 1 and subtract this element by this element. Good. And how we find inverse matrix? By knowing aggregate matrix and determinant of R. For this reason, I again open necessary information where we can read that by using these formulas. So what we need to do, we need to divide by our determinant and multiply by each element of our aggregate matrix. So we need to divide each element of this matrix by 1 divided by determinant. So for this reason is equal 1 divided by this and multiply by each element. Of course, we can fix our determinant and then we can just fill all elements of our matrix. And we are sure that everything is correct. So we can decrease the numbers, and this is our inverted matrix Z. But of course, there is more simplest way how to find this inverted matrix R just by using function MOBER, minverse. You know these formulas. So I use MOBER, you use minverse from this matrix, just to probably to check if everything is correct. And do not forget to click Ctrl-Shift-Enter. Good. And now you can see that everything is good. Everything is right. Yes, yes. So in this place, we just make checking of our all calculations. And now we can define by using these formulas are three values of F-criterion, because we have three kinds of independent variables. So F1, it will be equal Fj, so Zjj. If we want to F1, it will be Z11. Z11 is here, minus 1, and multiply by some component that has numerator and denominator, and it is equal 15 minus 3 minus 1, and we should divide it by m by 3, and also put it into the necessary parentheses, and is equal this value. Next, F2, the same, so we need to get Z22, the diagonal elements, minus 1, multiply by 15 minus 3 minus 1, divide by 3, and need to use parentheses, okay. And S3, it means that we need to Z33 take into consideration, minus 1, and multiply by what? 15 minus 3 minus 1, divide by 3. Yes, and now we need to probably to recall that if we want to make conclusion, we need to compare our estimated value with stable value. And for this reason, we need to use function Farrah-GLAUBAR. We use it when we find our criteria of Fisher into our previous laboratory work with level of probability again 0.05, put semicolon, then first degree of freedom, it is number of our independent variables 3, and if you remember the second degrees of freedom, it is n minus m minus 1, n minus m minus 1, this might be 15 minus 3 minus 1. Good. So it is our T table or F table, and if you take a look into our guidelines, you can recall that if our each Fj is more than Ft table, then the corresponding ith independent variable is multicollinear with others. What does it mean in our case? It means that F1 and F3 is much more bigger than table, and it means they are multicollinear with other variables that we analyze, and only F2 isn't correspond with other variable, and now we need to just prove that between the first and third variable presents a very strong connection, linear connection. So for this reason, the last R statistic is T statistic, where we use these formulas to find partial correlation coefficients. And you can see that we again use elements of our inverted matrix. Now we can find the partial correlation coefficients, and for convenience, I put the necessary formulas according to your matrix Z. And also, what does it mean, this kind of symbols. It means that we talk about partial correlation coefficient between x1, x2, when the third variable is hold fixed. The same between correlation 1 and 3 in the background when the second is called fixed, and the same, etc. So in this way, what we need to do? We need to use the element z12, 1, 2, divide by what? Coding or squared coding of what? Z11 multiplied by z22, and that's why. That's all. Next, we need to take z13, divide by, again, coding or squared of z11 multiplied by z33. And the last one, we need to take into consideration z23 divided by coding of z22 multiplied by z22 multiplied by z33. Good. And now we can find the statistics. The statistics is equal what? By using these formulas. So our correlation, the partial coefficient of correlation, we need to multiply by coding of 15 minus 3 minus 1 and divided by, again, coding of 1 minus this coefficient we need to put into the square. Times itself. Next. R13 multiplied by 40. And last. Good. So now you should again remember that we need to find table value of F-criterion. For this reason, we use well-known to us formulas, our function in Excel, stud-raspober. So stud-raspober with degree of freedom 0.05, and in our case, in the degree of freedom, and an n minus 1, 15 minus 3 minus 1, 2.2. And again, we go to our guidelines, and you can see that if module of your estimated value of t is more than table, it means that between factors xi and xj, present multicollinearity. So it means that only pair of two independent variable t1, 3, yes, reflect the strong linear relationship, and we prove that between the first and third independent variables present strong linear relationships, strong multicollinearity. And we need to do something with it. And according to our laboratory work, again, we go to our guidelines, and you can see that to eliminate multicollinearity, you need to make some replacement. So the factor x xj by factor xj, which must be equal xi minus xj. And if after all this replacement still will be multicollinearity, we need to exclude one factors from our laboratory work. For this reason, we go again to our Excel file, and you can see that in your Excel templates you have the new sheet. It is replacement, where you can see all necessary information from your data set. And what we need to do, we need to replace some R1 or X3, and then to see if it will be helpful for us to reduce multicollinearity with this pair of independent variables. So for this reason, we need to find what x1 or x3 we need to replace. If we take a look, what is x1? It is marketing costs. And what is total cost? So it looks like total cost is more general. And of course, it consists a lot of different type of costs, and marketing costs also will include into this economical indicator. That's why probably we can check if our marketing costs are not so influenced by total cost. And that's why we can do such replacement that x1 we can define like x3 minus x1. So if we do such things, it means that we need to create a new probably another color I will use. We define new values, so it will be equal x3 minus x1, x3 minus x1. So we can do for all our 15 observations, and it will be our view or our new variable x1, like differences between total and marketing costs. And now we will be doing the same thing for apply our algorithms to check if the multicollinearity presents, but probably it will need a little bit less time that we spent at our first time when we do it. So first of all, we need to define correlation matrix. For this reason, of course, we avoid to do a lot of calculation just by using function Excel. So for this reason, we just need to compare our massives of independent variable and x1, then x3, and then x2, x3. And in this way we can define our matrix. So we put necessary information into necessary field. Good. And then we go to method Farrah-Glover test and to find determinant. Of course, we can avoid complicated calculation, just use the same function that we use into this place, this mopred. From our matrix R. Good. Then we inverse matrix R by using inverse or mobber, and do not forget to click Ctrl-Shift-Enter, press a button Ctrl-Shift-Enter, and then we need to define by using these formulas our squared criterion, and probably if I copy these formulas, probably it will make no, but probably n. Instead of n we use this, and no. Why? Because instead of K1 should be our determinant. Of course, good. Yes, everything is correct. And now we also are able to define heterogram because it will be the same. So again, we can see that in our massive of independent variables present general multicollinearity. We go next to find our F1, F2, F3, and probably I just copy all of this, and then I just correct something that is necessary, but it is not necessary because we use, but no, I think it is not correct. Yes, we need to recall the formulas. So instead of first element, we need to use this element of matrix, matrix Z, then Z22 and Z33. Good. Now everything will be the same, and we can see that only F2 not correlate with other variables, but x1, x3 again correlate, and it's very, very big and strong correlation between them. Next, we can just to try now. Yes. So what we need to do? R12, it means Z12 divided by Z11 multiply Z22. Good. Next, again, we need to delete unnecessary thing, and Z13 multiply then Z11 by Z33. Good. And again. So Z23 multiply by Z22 by 33. Good. And now probably it will help us if we multiply these formulas. Yes, because again I can copy these formulas, you can see that it will be correct information. And again, table value is the same, and we can say that this kind of replacement do not give us the chance to improve the situation in our massive or independent variables, and it means that we need to extract some of x1 or x3 from our regression model. So to understand one kind of variable we need to subtract, we can propose or recommend probably to drop marketing costs, because a little part of this, because some part of this information is included in those total costs. And that's why into this laboratory work, we make such a proposition that X1 we just excluded from our regression model. And that's why our regression model will include only two independent variables. It is X2 and X3. And how to create this a regression model which include investments and total costs that have impact on income of enterprises, we will talk in later on the next part of this laboratory work.
And for this reason, we need to remind what kind of independent variables we need to include into our model. We extract x1 from our regression analysis, and we include into our model only two variables which is independent from each other. They doesn't have a strong linear relationship between each other, and that's why we can include it into our model. So still we will have into our multiple model only two independent variables. It is x2 and x3. So our SRF function, we will have such a view where y it is our estimated value of dependent variable y, and y it is the variable which we want to predict, to find prediction value. And we have only two variables. X1 it is our x2, or it is our investment in production, and next independent variable, it is our total cost. So if we want to create some econometric model, and in this case we want to create multiple model, it means that we need to find our unknown parameters a0, a1, and a2 by using what kind of formula? It's general formula which we need to use to find these unknown parameters by doing the same algorithm which we do according to firing unknown parameters into our only two variable model, where we have only one x and one y. So for doing this algorithm to find by using these formulas, first of all we need to identify the matrix X. You need to remember that we have three unknown parameters but only two independent variables, and that's why we need to put into first our column ones. 1, 1, 1 into all our rows. Then we go to our outputs according to x2 and put all this kind of values into this place of to define this our outputs matrix X. The same we do for our vector of dependent variable y, it is our income of enterprise. So next, our step is to find transpond values of matrix X. We need to fill all this matrix, then we fill all this matrix, and we transpond. Okay, good. Next, we need to multiply two matrices, and for this reason we use function mumnosh, and first our matrix, it will be a transpond matrix, and the next it is our X. Good. And Ctrl Shift Enter. Then we need to inverse the previous matrix, and for this reason we need to use function mobber. Then Ctrl Shift Enter. Yes. Then we need to multiply, and for this reason we need to fill all this matrix and use our function mumnosh, and we need to use this matrix by multiply by this matrix. Ctrl Shift Enter. Good. And if we multiply our last matrix by vector y, we can define all our unknown parameters. So again, we use formulas mumnosh, and we fill all this massive by vector y. Ctrl Shift Enter. Okay, good. Then we can create or just write our y estimated. This will be our a1 by x1 plus a2 by x2. Good. Then we need to test our model by goodness of fit by using coefficient of determination. We need to use these formulas for to find these formulas. First of all, we need to define our estimated value of y by using our multiple regression model or regression function. So what we need to do, we need to use a0 plus a1 multiplied by x2 plus a2 multiplied by x3. And now we need to fix our unknown parameters, and then we can extend and define all our estimated value of y. Then we need to define the differences between each our estimated value and mean value of y, and mean value we find into our first step of doing this laboratory work. Again, we fix it mean value. Then we need to find the square of these different differences. Then we need to find y. It is our actual value of y. It is our this value of y minus mean value of y. Again, fix this value, extend, and define the differences and square of the differences in square. Put it into the square. Good. And now by using this formula, we can define our coefficient of determination. It is our estimated value minus mean value, this kind of value, divided on this kind of value. Good. So if you remember, if our coefficient, the value of coefficient determination go to 1, to the limits of 1, it means that our regression function is appropriate to our outputs. So we can say that our testing of goodness of fit is positive. It's good, and the next our testing of quality of our multiple model is testing of significance by using F-test. And for this reason, we can use two kinds of ways. We can use the first way based on coefficient of determination, and you can see these formulas, or we also can use this kind of value by using the differences between our y estimated value, mean value, and actual value. So probably the first formulas is the most probably simplest, and we can just calculate this. So we need to use this kind of value, then divide it on 1 minus coefficient of determination, and then we need to multiply all this kind of proportion on our degrees of freedom, where n, we go to n minus m, it is our x2, x3, it is equal to minus 1 divided on m divided on 2. So we need to put brackets and enter. So we have 31.1, and to find F table, we need to use FARRA-GLAUBAR, by using level of confidence, it is R05, then n minus then m2, and n minus m minus 1, it is equal 15 minus 2 minus 1, it is equal 12. Good. So if our estimated value is bigger than table value, it means that our model is significant, and also we can check this kind of value by using the second part of these formulas. So we need to define differences between actual value of y and estimated value of y, and put it into square, and then again we need to find this the proportion between y estimated minus mean value, y estimated this kind of value divided on this kind of value, and this proportion we need to multiply by another proportion between K2 and K1. K2, it is n minus m minus 1 is equal to 12, divide on K1 is equal to divide on 2. And again, so we will check that we made all our correct calculation. Good. So if our model is significant, if our estimated parameters and again or our function, regression function, is good to fit to outputs, it means that we can make some prediction based on this model, and we can define our predicted value of y. First of all, we need to write our model, multiple model, in the view like this, in expression like this. So first of all, we need to put our A0, then we need to put our A1. This kind of parameters should be multiplied by x1 predicted. So we go to our outputs and we can find that predicted value of x2 is equal 30.01. Then we continue and we put into this kind of place our parameter a2, which should be multiplied by, and we look at this expression, by x2, predicted value of x2. So again, we go to outputs and our predicted value of x2, and this is our x3, or our total cost is equal 41. So we have our basic expression to find predicted value of y, and we just need to do some calculation. Very simple calculation by multiply each our regression coefficients by their predicted value of independent variables. Good. So this is our predicted value of y. But we also need to find confidence interval of this value, and to find this confidence interval we use these formulas. So we need to find delta, and for to define delta we need to find first of all t table, or table value of t criteria. You probably remind that for this reason we need to use Skewed-Raspober. We need to put our level of probability, which is equal 0.05. Then our degrees of freedom, it is equal our n minus m minus 1, which is equal 12. Good. So this is our t-table. Then g-residuals. For define g-residuals, we need to use this formula. So again, we put function coding. Then we need to find these differences. This is difference between actual and estimated value. It is this kind of value divided by, again, n minus m minus 1, which is equal to 12. Good. And now we need to find this expression. To find this expression, what we need to find, first of all, it is our matrix of predicted value of x. Again, remind that we have two independent variables into our model. This is our x2 and x3, or x1, x2, and we need to put this kind of values into this matrix, and the first matrix will equal 1. Why? Like we do the same procedure for identification this outputs matrix of x, and next our predicted value of x2 is equal this value, and this value is equal this value. Good. This is our vector or predicted value of x. And now we need to transpond, to define transpond matrix. A special insert, значение транспонировать. Okay. And then we need to inverse. No, not inverse, but we need to multiply this kind um, matrix, yes, by using mumnoj, by this kind of matrix which we inversed from the our OLS method, which we use to define our unknown parameters. So this is our matrix. So we need to use this kind of massive and Ctrl Shift Enter again. And then we need to again multiply the previous matrix by vector of our predicted value of x. So we need to use mumnoj, and we use this kind of values. Ctrl Shift Enter. Good. So next, our step is to define this expression. So we need to use scoring from this kind of value plus 1. Good. And now we can define our delta y predicted by multiplication of 3 elements. And now we can define, we need to put our predicted value of y in the middle, and then in this side we need to extract our delta, and in this part we need to add our delta. Good. So we can say that with this probability of 95%, our predicted value of y will be lead between 56 to 86 thousandths UR. Good. So the last our task is to determine the partial elasticity coefficients for the forecast, and you should probably underline that we talk only about forecast or predicted value of y and of our independent variables. So for this reason, we need to use this expression, and the question is how we take the derivative of the expression like this. How we can define the dy dx1 predicted and dy by dx2 predicted from by using this expression. So, for example, partial derivative, the dy by dx1 predicted will be equal what? This kind of our part of this coefficient will be equal a1. So we need to put equal a1, where we can define this a1 from this, for example, or from this place. Then we need to multiply this kind of values by proportion between predicted value of x1, where is predicted value? It is our predicted value of x1, which should be divided by predicted value of y. Good. And the same algorithm we use to define our coefficient of elasticity for x2. So partial, how we can take the derivative of x2. So it will be equal from our again expression from this part, yes. So we look at this expression and we can define that our partial derivative by x2 predicted will equal a2. So we put equal a2, so this is equal this kind of value or on this kind of value, yes, and should be equal on x2 predicted value of x2, which is equal 41, divided by, again, predict value of y, 71. Good. And all these coefficients can show us how our y will change if in first case x1 predicted will change by 1% if x2 will constant, and in the second case how our predicted value of y will change if our x2 will change by 1% if x1 will be constant. So this is finish of our laboratory work number 4.